Good afternoon. Our team consists of 5 members: team leader Baek Yi-hyuk and members Song Ye-won, Shin Ju-young, Oh Dong-jin, and Jo Sung-hwan. We have chosen improving performance of transparent and flexible thin film heating system using silver nanowire based crack template as our presentation topic. We divide the panel of contents like this. In the research background, we will discuss the necessity of flexible and transparent thin film heaters. To explain why transparent flexibility are needed, transparent heaters allow for a wide field of view without visual obstruction. Flexible heaters maintain stable performance even in flexible electronic device and can be applied to various shapes of curved surface. Therefore, they are being developed for use in various fields such as displays, wearable device, and smart windows. Our research topic, transparent and flexible thin film heaters, is also listed occasion as a next generation thin film heater with a significant market potential. As you can see, left graph below, global flexible heater market size shows an upward trend each year. Similarly, the right graph, global transparent heater market size also shows an upward trend each year. In the next slide, we will explain the disadvantages of the existing Indian thin oxide thin film heaters. First, we will have capitalized the characteristics of the existing ITO thin film heaters into flexibility, mechanical durability, and thermal stability. The left photo below shows ITO thin film heaters with low flexibility. In terms of flexibility, they are flexible due to their glassy ceramic material properties. The next photo shows ITO thin film heaters with limited mechanical durability. In terms of mechanical durability, they play under repeat operation and exhibit hotspot phenomena due to uneven resistance of curved surface. The next photo shows ITO thin film heaters with low thermal stability. In terms of thermal stability, similar to the flexibility issue, they are flexible due to their glassy ceramic material properties. Therefore, in the next slide, we will explain the improvements made with AGNOW thin film heaters compared to ITO thin film heaters. We have chosen AGNOW material to improve the problems of the existing ITO thin film heaters. The advantages of AGNOW thin film heaters include excellent flexibility, high mechanical durability, and excellent thermal stability. Regarding the right photo, the thin and long structure optimize network formation, providing high conductivity and transparency while maintaining excellent performance in the physical sets and thermal environments. However, a limitation of AGNOW is the heat generated at the junction can lead to high resistance, causing the junction to break and degrade heater performance. The right photo shows the junction breaking or being destroyed due to high resistance when heat is generated at the junction. Therefore, our goal is to create a heater using crack template technology to solve this problem. Thank you. Now I pass the stage to Song Ye-won for the next part.
Let me explain the structure of the heater we want to make. The picture on the left shows what the heater will look like. The heater needs 2 layers. One is the heating layer and the other is the current spreading layer. We plan to use silver nanowire for the current spreading layer and aluminum zinc oxide for the heating layer. Looking at the structure, first we attach a PET film to the substrate. PET film is very transparent and flexible, so we need a sturdy substrate to support it. That's why we use a strong handling substrate. To create the crack template, we use a material called silica. Coated silica is a material that helps form a special layer called an electrical double layer, which is made when sodium in the silica particles stay in place. When used, silica dry, it won't crack because the molecules inside stick together. These cracks are important because they help the silver nanowire stick better. Next is place the silver nanowire on the prep layer. If you look on the right, you will see a picture showing silver nanowire applied on top of the cracked layer. This prep layer technology helps make the harness area bigger. Even if the crack happens, the silver nanowire stay connected like fibers, which helps create a patch for electricity to flow smoothly. Plus, it's flexible and clear, so it can work with flexible, clear material like PT film, which makes it perfect for devices that need to bend. After that, we add a filling layer, which is made of aluminum zinc oxide. AgO is great because it has low electrical resistance, meaning it lets electricity flow easily. It also handles heat well, so it won't break down easily. Plus, it lets light pass through and keeps it from escaping, making the heater more efficient. Finally, as you can see, we use silver paste. The reason we use it to make the process easier. Instead of using a mask to deposit the phosphor, we decided to use silver paste, which is a conductive material to create the phosphor. This makes the process simpler and quicker. Now I will pass the stage to Eunjin for the next part.
In the research method section, I will explain the experimental procedure. Let me explain the process flowchart. Please refer to the detail of the process next to the picture. First, we clean the handling substrate and the PET substrate using an ultrasonic cleaner and dry them with nitrogen gas gun. Second, using a spin cutter, the colloid silica solution is coated and then it is dried with a hot plate to create the crack template. Subsequently, the silver nanowire solution is coated onto the generated crack template using a spin cutter and then dry using a hot plate. Next, by removing the generated crack template using an ultrasonic cleaner, a pattern silver nanowire layer is created to form a front spreading layer. After forming the front spreading layer, silver paste is coated on both ends of the PET substrate with a width of 0.5 cm to ensure the exposure of the silver paste in the final step. Captain tape is attached onto the silver paste coated area. Finally, after separating the PET substrate from the handling substrate, an RF sputtering process is used to deposit agent, forming the heating layer. Following the deposition of the heating layer, the Kapton tape attached earlier is removed to expose the silver paste, thereby forming the transparent and flexible thin film heater. Thank you. Now I will pass the stage to Shin Joo-young for the next part.
I'm going to talk about measurement tools. To check if a heater works well, we need to see if it gives off heat evenly. If some parts get too hard and others don't, that's a problem. To check this, we use a summer imaging camera which takes pictures of heat. Since heaters are used in things like phones and cars, they need to be flexible. We test this by bending the heater several times and checking if it still works properly. Next, we measure electricity. We use special tools called probe station and 4-point probe
to see how electricity flows in the heater. If electricity is spread out evenly, the heater can warm up properly. We also check if the heater is see-through transmittance. We use a UV-VIS spectrometer to measure how much light can pass through. With a special crack template technology, the heater can become even clearer. We compare it to older versions to see the difference. Lastly, we look at the surface of the heater using a microscope. We use an optical microscope OM to measure small cracks and scanning electron microscope SEM to check the silver nanowires. By checking the line width of the crack template and the silver nanowire, we will find the line width suitable for the heater characteristics. Now, I will pass it to Miguel for the next part.
Finally, I will tell you the role of each team members and the research spread. First, as we mentioned earlier, we make a pre-template using silica. At this time, the appropriate line widths and distribution are important, so we will study and code them with Shin Jung as the main member and the helper of two members. The current spreading layer, silver nanowires, will be managed by two members, starting with Ongji. And ASIO will be deposited by searching for a lot of data, starting with Johawan, and this will be deposited. We report our research report will start with Sungyeon and method starting video. Therefore, all members participate in our research. Based on this, we make weekly plan. We plan our work through a meeting in March, and through this meeting, we decide to schedule a long time of approximately 5 weeks to find the optimal line widths and distribution for crack template, because it is important process in our work. And after that, silver nanowires should be used as our current spreading layers to follow current evenly through the entire area of the device. So we plan to check the optimal thickness and proper current flow over a period of approximately a month. And since the heating layer is generated, we plan to study it over a period of a month to check the most efficient thickness and processing parameters. Finally, the measurement is measured before remaining in the next process to check how ideal the size, thickness, and conductivity come out in each part of to make the most efficient thin film heater. Finally, in June, we moved to draw the most optimal process parameter at each result, make our complete version, and submit it to the test and conference, where finish the announce of our comment. Thank you for listening our presentation.